So, hello guys. Till now, what we have discussed? We have discussed about the propositional logic. So, if you have not watched the videos on these topics, please go to the playlist whose link will be you will get on the description in the description box. All right. So please go through description box. You will also get the links of your Telegram channel. All right, Telegram channel, and also the link for what you will get link for classroom where you can submit the assignments. All right, so please go through the description box. Please go to description box and access the playlist. All right, so please before going to this topic, you must watch the video on that topic in which I have explained the propositional logic in very easy manner. All right, so please go and access the complete playlist. And please, if you want more videos like this, so please subscribe and press the bell icon so that you can get the notification for each upcoming lectures on time. Okay, I am also taking lectures on C++ and Java. You can also go to my channel and watch those videos. I am taking these two languages combinedly. So, because they are very similar, the difference is only in the syntax. So, please go through those videos and learn the programming. Now, coming to our today's topic. What is today's topic? Our today's topic is Boolean algebra. Right. So, we are going to learn about Boolean algebra. Boolean algebra. Please emphasize more on the words rather than on the what I am writing, because I am only writing to make your attention towards the screen, but you have to listen the words carefully, because listening words carefully will make you understand the topic carefully. All right. So now we are heading towards Boolean algebra. So how this Boolean algebra came? This Boolean algebra came from the propositional logics. All right. So we were needed propositional logics. All right. So now from this propositional logic, we are going to transfer into Boolean algebra. See, if you have not learned propositional logic, please learn it, because it will help you to understand the Boolean. So in this context about the Boolean algebra, hope you have already know the concept for the truth table construction. If you are not able to draw the truth tables, please go through my previous videos in the propositional logic lecture. I have explained how to draw the truth tables and what are they. So repeating again, truth tables are what? The tables which shows the value about the truthness. That is how an algebra expression is true or false, and for what input values it will result in truth value and in the false value. So now, what are the Boolean postulates and laws? So we are heading towards the topic Boolean postulates and laws. All right. So, what is the first law? First law says that properties of zeros and ones. Properties of 0 and 1. So, what this law says that I think you are familiar with the Boolean algebras topic, like Boolean, not Boolean. Yes, we consider binary ones. All right. So you are familiar with addition and subtraction. So now, what if I add one? If I add one to our expression. See, this is something you can call it as expression. Expression A. When you add 1 to this, then what it will return? It will return 1. See, these are the values which are determining whether it is true or false. So when you add something to any expression, whether it outcomes in false or true, it will always result in the true. Means if your, see, this is your expression, and I have explained you about propositional logic and expressions in the previous videos. So if you don't know, then go through that video. But now if I say that this is expression, it is returning either 0 or 1. 0 means that it is true, it is false, and 1 means it is true. So when I add 1 to 0, or when I add 1 to 1, so what it will return? It will always be true, because when we add something to true, then it is always true. And now please don't think it like binary, but it will result into 1, that is true, because I am saying that if I have said the truth. All right, see, just take an example. Take example of daily life. All right, I have asked you to say the truth. Okay, and there are two brothers, and I asked both of them to say the truth. All right, one said the lie, and other said the truth. So now, if I already know the truth, if I already know the truth, and just I call them to ask only to see what they are saying, but I know the truth. So this is their opinion, or this is their verdict. But now, if I know the truth, I concluded the truth. If I concluded the truth, so what will be the outcome? The truth will be revealed. So it is, the truth will come out. And when the truth is already told by the victim, and I also concluded the truth, then this will return in the truth. All right. So now how it's truth? And now, if I suppose, okay, if I suppose that if I don't know the truth, okay, then what will happen? See, this is second part of this. This is first part. This first part. Now this is second part. What does this second part says? That if I conclude false to any expression, whether it is true, it is false, then it will be the expression itself. All right. So taking the similar example, so if someone came to me, he told me false, and someone told to me the truth, but I am the supreme leader. I am the supreme leader. All right. So now what will happen? See, I don't know. See, this represent I don't know. All right. I don't know the truth. So if I don't know and he is not telling the truth, then the whole expression will be 0. That is what? That is the expression itself. That is A. Now this is also A. All right. If I don't know the truth and he told me or she told me the truth, then what it will return? It will return that it is truth. And what is this? The one means this is the expression A only, because I have replaced A with this and with these values. So when 0 comes, then the expression, and when 1 came, then also this expression. But this is another statement. Do you know the difference between statement and expression? If you don't know, then please go to my programming lectures, and in the lecture, I think it is operators. Yeah, it is operators. I have explained you the difference between the expression and the statement. So now you have got till now what are the rules, that when you are getting A as expression and you added 1 to it, then it will return in the 1 only. It will directly go to 1. When you add 0, then you will get A. All right. So these are 2. Okay. Now what other one says? See, in the Boolean algebra, you get an advantage. What? If you know the 2 expressions, then you can also derive, because there are only 2 cases. That is this one and this one. All right. This is known as what? I will tell you in the upcoming lectures. But for now, remember this, that now you can convert this into this. So now these 2 statements can also be written as this one. This is what 1, and this is what A dot 0. So what will it give now? See, in the addition, you said that the truth one has dominance, but now in the subtract, in the multiplication, what will be going to do? See, when you multiply anything with 1, what it will return? It will return A itself, or that thing. But when you multiply 0 with something, then it will return 0. So what this law? Again, this is the third part of this law, that is properties of zeros and ones. And what are they? A dot 0, A dot 1, and A dot 0. They will return A and 0. Now, if I say to draw the truth table, if you know, then pause the video and try it by yourself. But I will tell you that truth table for suppose I will tell you for this and tell you for this, and for these two you have to construct on your own. That I am explaining you what you have to do and what I am doing. So now, if I say that I have to draw the truth table for this. So how will I construct? See, you can derive the results from truth tables also. So how will you construct? This is the table. These are the input. That is A 1, and what is it? What it is? It is the output. So what now? See, this has to be calculated, and you have to bring that all the values in this are 1. So now, if there is a single expression, then how many values? I have explained you in the previous lectures. If you have not watched, go to that. But in this video also, I am telling you. See, there are 2 star number of this these operands. All right. So if I say that there is only one operand in this expression, that is A itself. So how many values input values I have to feed? I have to feed 2. If suppose there is written A plus B equals 0, then how many values I have to feed? I have to feed 2 power 2, that is 4. All right. Now what I will do? There are only 2 possible values, that is zeros and ones. So now see the and now what 1 will give? It will always remain 1. Now using the using the logics, all right, what you will get? You will get that 0 when added to 1, it will give 1. 1 added to 1. See here. Now think like this. This is what? Addition. Now what will it give? See, when you in the addition, this is a very special case that when you add 1 and 1, then it will return 0 and 1 in the carry. So what carry will do? Carry will again also add it. So it will be 1. This is a special rule which is for Boolean algebra. So now for this, the truth table will be constructed like this, and what you are seeing that all the values are 1. As I have told you that A plus 1 is 1. Now if I construct for this A dot 0, so similar one, zeros, A, I take input as zeros, this and this dot A dot 0, now 0 and 0. So you know 0 and multiplied by 0, it was 0, and when 1 was multiplied by 0, it also results in 0. So what is the output? What are all the outputs? 0. So what this expression results in? 0. Now you have understood. Now it's your turn. This is assignment 1 of this lecture. Assignment 1, that draw the table for what? Which values? Draw the table for A plus 0 equals A, and A dot 1, and prove that. Like similarly that I have created the truth table, you have to construct by yourself. All right, please follow the method. You will definitely be able to draw. Now what are the next laws? Next law is complementary law. Okay, second law is complementary law. See, think complementary law, and I have told you in this section that when you are having this, then you have to convert into this. In the properties of 0 and 1s are the only one. zeros and ones, because there are two values, 0 and 1. So there is one property for two properties for this, two properties for this. So similarly, every law has the two properties. What are they? So now, if I write just like there, I wrote a plus 1. I wrote there in the upper part. But now, if I write what is complementary, if this is properties of 0, if I say that there is complement, so if I say this is expression and now add complement to it, all right. And similarly, when I convert this into dot, what will be converted? What will be known? It will be written as this. All right, a dot a dash. A dash represents what? Complementary. That's why I said you to watch my previous lecture where I have explained all these concepts. Okay. Now what you have to do? Okay. Now I am telling you. See what this will result in. Okay. You can also derive the result via truth table. But now here I am telling you, when you have a and you have complemented a dash, then it will represent in what? 1. And when you have a and you have complemented 0. See, if I draw the truth table, you will get a better understanding. For now, learn these values, but I am drawing the truth table also here. See, there are one single variable. It is complement, so complement is counted as like the that one only. Is not a different variable. If complement means that just the opposite of that number. All right. So what it is? A, and this is a dash, and you what are a plus a dash. So what are the values? If I say that two values, zeros and ones. So now what is complement of 0? It is 1. What is complement of 1? It is 0. So when I add 0 to 1, it will result in 1. When I add 1 to 0, it will also result in 1. So what conclusion you have drawn? That you can also check the results from the truth table. Now, if I draw for this, see, I am drawing for this to explain you, but from the next one, you have to see now a dash, like what I have did, what I did there. Now a dot a dash. So now two values, 0, 1. What is 0 to 1? 0's complement, that is 1, and what is complement of 1? That is 0. Now, if I multiply this with this, what will I get? I will get 0. When this one with 0, then I will get this. See, you are seeing that we are drawing results from these truth tables. This I have told to remember, just to remember, but you always try to draw the conclusion from the truth table. Now, what is next law? Which is the idempotent law. Idempotent law. All right. So now, what is idempotent law? It says that the similar operation will be done with the same variable. Means the variable will appear twice. That is identical operands. So what is this? See, suppose I will draw the truth table and you will draw the conclusion. All right. So suppose when I have written here, what I have written there, I have written that this plus, and see, I have written this, and then I replace plus with this. Now idempotent law states what? That you have to uh, operate with the similar ones. So this. So what you will get? You will get the same there, and also here this. Idempotent means the same result, same operands. Same operands you have to use, and you will get the same result. If I have to prove this one, how will I prove? Suppose this is A, and also this is A. So they will take similar value. So 0, 0, 1, and 1. What I have told you? What I have told you? 0 and 0, it will generate result what? 0. And what this will generate result? It will generate 1. So what you have concluded? That what is the operand here? See, And what is the result here? This. This is operand, this is value of operand, and this is value of result. So value of operand and result are same. So we have written here this one. Like in maths, if I write this and with this, if I add or something, I say that if I do some operation here, whether it is addition, multiplication, or what is, and if I get the same, suppose if I uh, do some any operation I do, and with this one, and I get the same result whose value, suppose is its value is 5, and I get the result as 5, then I will replace this one with a. Okay, just like if I have got this expression plus 10, uh, and I get after solving its value was what, something I get and which is similar to x. So what I will do, I will replace its value with x. All right, the whole expression will become x. Okay, now you have to draw the truth table for this. Draw the conclusion. This is your second assignment. Got it? Now what? Involution law. Fourth one is involution law. This is fourth one. What involution law says? That it is simple law and it has only one expression, that you have to make a double complement. So if you have taken this, you have taken this, then what it will result in? It will result in the operator itself. This is operator, operand, sorry. Now, how you can conclude this? See, how can I conclude this? If I draw A and I have to write its complement also. Now, what is the result? I have to complement and also make its double complement. So what? If there is one operand, there is one operand, so there are two values involved, 0 and 1. What is the complement of this? This is 1 and 0. Now, I have to again complement this value. So when I complement this value, then what it will result? It will result in 0 and 1. So what I can see, this value are same. This value and this value are same. So this expression will be equal to this. So I have written that this expression is equal to this. Now I thought you have got. See, if you are learning or if this topic is in your course, then you will easily grab it. But if you don't have these topics in your syllabus, of course, then it might be possible that it is difficult to grab. But please try to grab this, because these are some logic building chapters where you, just like what I have said, that draw the truth table and draw the conclusion. So from this, when these things, you can draw the logics, that how you will get the logics, how you will just to create the logic, how you can create the logic. So in the similar way, you should know that how you can generate the logic. So please, in my opinion, please go through all the videos. It will help you a lot. All right, now let's moving forward. Now let's moving forward towards our next topic. Okay. Sorry, not next topic. It's the next law. That is fifth law. What it is commutative law. In the commutative law, what it's said. See, commutative law uses two variables, that are a and b. And what it says, that when you are having this expression, then replace a with b and b with a. So these both expressions are equal. All right, and also when you, I already told you that when you see, there is no use of dot or plus, so we cannot convert this from this or this from this and this now. But we as we are given the plus symbol, then we can convert this into dot. So what A dot B will be similar to what? Here we can also generate the logic, the conclusion that B dot A. So if we replace A with B, see, I have replaced A with B and B with A. See, what I have. So what this will be known as, this will be the same results. All right. If you calculate this left hand side or right hand side, both will be equal. That is LHS, sorry, RHS will be equal to LHS. Left hand side will be equal to right hand side. Now, how you can generate this? I will be giving you truth table for this, and this is your third assignment, I think. You can, yes, it is your third assignment to draw the truth table for this. But now I am giving you the truth table for the plus one. So I have told you that A, this will take A, this will calculate A, this will, all right. Now, what I have told you have two operands, so you have to fetch four inputs. What are they? See, this is A, this is B. I have told you that see, there is one. So what are the possible values? Zeros and ones. All right. But when you have four inputs, then you have to start from 0, then go to 1, then go to. I have told you earlier in the earlier video that how you have to generate these values, these inputs. Like just simple trick is write 0, 1, 2, and 3, and consider this as first and second, these as bits. So now, if you take it and take these as bits, so how you can generate 0? You can generate 0 like in this way. You can generate 1 like this, and you are going to 2, so like this, and 3, what it is written, 1 and 1. So use similar ones, 0, 0, 0, 1, 1, 0, 1, 1. Now you calculate A plus B. What you will get? 0 and 0, this is 0, 0 and 1, this is 1, 1 and 0, this is 1, and 1 and 1, this is what? 1. Alright, that is true, and there is, you are facing true, good, then it is always true. Now calculate B plus A. Alright, so now when you calculate B plus A, this add this one from right to left. Alright, this is 0, this is 1, this is 1, and this again 1. So what you are seeing, that these values are equal. See, this is one of the way to prove some Boolean expression. This is also a Boolean expression or statement, you can say that. So this is a method to prove. I will give you questions regarding this. But for now, as your third assignment, draw the truth table for this. I have explained you for this one. You have to draw in your third assignment of this lecture the truth table for this and prove that these two values are equal. Now the next law is what? Distributive law. All right. So what is the distributive law? Distributive law. What does this distributive law says? See, the distributive law, there are use of its variables. So now, how to see? This is multiplication, and this is the summation. That all you can say that addition. Now, if you know the general mathematics, how you can expand this? When you are given in your classes, when you you are studying maths, that you have encountered with this, then how you can handle this? You just simply multiply this, write this, and again you use this operator, and you just multiply this and write it here. Similarly, this is here also. See, multiplication is done by dot operator. So this multiplicative law, C represents that when you write this. See, understand like mathematics, it is very simple. So just I'm not telling you that how it came and all that. Just think it like mathematics, and like in the mathematics, this is the result. So for the distributive law, you can just simply remember that you have to distribute. You have to distribute A among B and C. So how you can distribute? You can give some part of A to B, and then again some part of A to C. Now, how you can generate the second form of this? Just replace dot with plus, and this plus to just transform this dot. Now, what is coming? You are like this, and in the bracket is you if you remove the bracket and replace it with dot, then you will get this. All right, this is your expression. And now you can also generate the uh, output when you know output of one expression. So what it can be? It will be dot replaced with this addition. All right, and then this plus is replaced with dot, and then again like this. So distributive law is this. So these are two distributive, and see, this is first and this is second distributive law. So if you have to see, this is your assignment. This is your assignment 4. Assignment 4, that you have to draw the truth table for this and prove that these are equal. I have said earlierly that this is one of the methods to prove the result. So prove the result by drawing the truth table. All right. Now moving towards our next law, that is associative law. All right. Seventh law is what? Associative. See, associative law, there we use again three variables. And what does it says? Here we have distributed, but in the associative law, we will associate. Associate means we will work in parallel to it, not distribute. So for working in parallel, write this. Oh, sorry, if I explain you in better way, just think like this. See, if this is the working committee, think like that is this is the working committee. This is plus, this is C, and now I have to associate myself. So how will I associate? I will just add myself to them. What it will result? It will result in the similar way that we have got there. Just if I have used this, then it has converted to this. So now, but here the result will be different. Here we will get what? If C, if some of these two colleagues which are already working and collaborate with me, then also the same results will be generated. See, simply in addition, if you add three numbers, all right, suppose there are three numbers 1, 2 and 3. When you add in this order, then what is the result? It is 6. But when you add, see, when you add these two first, then you will get 5. Then add 1 to this, then you will get 6 only. And when in the second case, when you add first these two, and then add 3 to that is 3, and then 3, then also you will get 6. So simply learn these like the mathematics. Now for the second form, what I have told you earlier, that replace plus with dot and dot with plus. So what will I get? I will get like this. And here I will get what? If I multiply this and this and then this, then I will get the same result. You can confirm it, you can learn it by the trick that it is like mathematics. Now what is our final law? This is absorption law. All right. Eighth one is absorption law. What is absorption law? See, as you can see from this, the name, that something is going to be absorbed. That is, something is going to be dismissed, or you can say that is going to be finished. All right. So suppose this is given. This is the expression. You just simply learn like this. So now, what is dominating? A, and what is not dominating? That is what is recessing is B. So B will be truncated, or you can see B will be finished by A. So it will give this. All right. And now, if I have to generate second result, then what I will do is as simple as that, like this, and it will also generate result this. See, if I try to explain this, all right, if I just use this, all right, I am explaining you this, then you can understand this. Also, you can use the logic of truth table to prove these ones. All right. So now, how I can conclude this result? View result. It is very simple. Just like A plus B, and what? How you can generate? See, use distributive law. Use distributive law. All right. So this is what A dot A and plus A dot B. Now this is what idempotent law. What it says, when the same variables, then result will be the same yes, same variables. All right. And what it will represent? It will represent A dot B. Now see, take common A. What if you will get 1 plus B? What the properties of zeros and 1 says that, and when you add 1 to something, it results in 1. Now this is 1. All right. This is what I have to get. Now what this property of 1 says, that when 1 is multiplied by A, then same variable is returned. So what is the result? This one. See, this one is proved from here. So you can say, like, to prove that one, you can use this. All right. So now, and you can use the second method, that is truth table. Okay. I think you have understood the concepts till here. So now, let me explain you the last one. Sorry, no, this is not law, but this is the theorem. This is De Morgan's theorem. So De Morgan was a great mathematician who developed two theorems, which brought an immense utilities in the Boolean algebra. What are these laws? See, this is one. This is the most important one. What you have learned here, you will be going to apply using these two laws. What is the first law? First law. See here, what it is. What I am going to explain. I am going to explain De Morgan's theorem. So De Morgan gave us the two laws. What was the first law? First law was saying that if I add two numbers and take its complement, then what is the result? It will result in the multiplication of separate complement of each one. That is A dash and B dash. And what does the second result will come up? I have already explained you that when you have to generate second one, then just replace this to this, or this to this. So if you know this result, then you can generate the second one, and if you know second one, then you can generate this one. So what is this? What will be this? This is like, if I get the multiplication of two numbers and I take complement of that multiplication, what it will result? It will result in the multiplication of two complemented numbers. All right, I think you have understood. So now you have to prove. I've explained you that how you can use the above laws to prove. Now you have the assignment. What number? I guess assignment 4. Now assignment 5 will be what? Assignment 5 is what? Assignment 5 is what? To these two laws by truth table. De Morgan's theorem with truth table. And what is assignment 6? Prove De Morgan law. See, I am explaining you the first one. Second one, you have to prove the assignment 6, prove second one using Boolean laws, not the truth table. So I am explaining you the first. Using that, you have to prove the second. So if I take like this, that I say that it is A plus B, and what I have again taken, I have to consider its thing. I have to take complement of it. All right. So what we know that the sum of a variable and its complement is 1. I have already told you the complementary law that when the sum of a variable, that is a, and then its complement, its, that is a dash, is what it is 1, and if I multiply these two, then what will I get? I will get this. All right. So we will be using these two. So if I say that this is complete expression as a, and I replace this a with this expression, what will I get? I will get a plus b. All right, a plus b, and then what? Uh, this plus a dash plus b dash equals to 1. And second one, what will I get according to this? A plus b, sorry, a plus b, and what is the second expression? And here the second expression is what? Second expression is the right hand side, and first expression is this one. So what will I get? I will get a plus, sorry, a dash. In the first one, it was mistake. It was this, and in the second one, what it will be going to? It is going to be like this. This is a plus b, and what is this? A dash. Uh, yes, is and dot b dash. All right. This is dot one, and this is also dot, because I have told you that this one can be converted to this, but this is what? This is a, and this is what? This is a dash. So these will be written as it is. So you have to make this a and a dash. Okay. So what is the result of this? This is 1. This is 0. Now consider this second case. If I take the second case, okay, what it is given? It is given a plus b, and what? A dash dot b, and this is what? Dash. So it is what? 0. So now if I try to expand this, see, when I expand this, what I will get? I will see, these are two multiplications, so this will result only in 1, and if I have the sum 1, then I will multiply this with this with this. So when I multiply a dash and b dash, and what it will return? It will return a dash b and b dash. So what will it be? What it will conclude? See, when you see using the complementary law, what you will get? You will get 0 into b dash plus a dash into, and similarly here you get 0. And using properties of 0 and 1, you will get 0 plus 0. And what it is? 0 plus 0 is 1 only. Oh, sorry, it is not 1, it is 0. Okay, now using the second case, see, using the second as this one, this is first case. Now I have explained you the second one, but this is first one. Now if I take the second case, then what it is? A plus b, and what is a a dash. Now what? It is A dash dot B dash. All right. Now what you have to do? Use the distributive law. And using distributive law, what you will get? You will get A plus B and add one pair with this A dash, and also see this. What it is? A plus B and what? Add this pair also. See, just open the distributive law and check. Am I right? Yes, I am right. Alright, now what it is going to be? When you add complement to something, then it will result in 1. If you add these two, then you will get this, and 1 is here. Alright, now what it is? Now see this A, and what is this? This is 1. Now what? This is 1. And sorry, it I think I have done some mistake. And here. Oh, this is 1 and 1. This is 1. Alright, so I have proved this. So the result is same. Okay, so result is this one, this one. So you can prove by these two methods. The second method I am not giving as your assignment, but you should try this and try to solve it and that using the but please be honest. All right, now solve it by your own self. Now in the beginning I told you that you have to convert this with this and this with this. So what this is known as? This is known as demorganization. What it is? Demorganization. When you convert dot to plus to dot, it is known as demorganization. Alright. And when using when you do this, and in addition to that, you convert 0 to 1 and 1 to 0, then these both demorganization and this rule is combinedly known as principle of duality. All right. So now I think I have explained you too much stuff. See, this last chapter is going to be bigger now, so I can take more time. So I will extend the date for the assignment submissions for the lectures from now. But for the previous one, the date is same, that is fine. So let me conclude this lecture here only, and thank you all